Okay, this is definitely the slow boat to integration by parts, because by the time I got to this point in calculus, I was so lost. I had to rethink a lot of things, and one of them was x. Somehow I missed the memo. This is what I mean. When we start this math journey, we see a lot of things that look like this, and this is a call to action. We're going to be solving for x. And we spend a lot of time solving for x. So much time solving for x that when you get to calculus and see some things that look like this, there's that 3x again. We're thinking, don't we have to solve for something? It's very disorienting. And the big shift, the big break with algebra, is that we're no longer solving for x. Now we're choosing x. We choose x. Actually, we're choosing x twice, and we write one of those choices here and the other choice there. And the reason we're doing that is we're creating a boundary, a definite boundary within infinity. So within that boundary, we can measure something in square units. We can measure the area in square units. And I'm going to try to be clear about what I mean by all of that. So here's that function that I just had in front of you. It's y equals 3. There it is, written in calculus terms. The function is y equals 3. And what this means here is that what it's asking you to consider. It's asking us to consider that an area between the x-axis, the dx, between the x-axis and the function line. And this function line just happens to be y equals 3, so that's how it's expressed. So we're considering this, but it's an infinite area. And we want an area formula for it, and we call that the integral. This video isn't about how I know that's the integral, but I will tell you that there's many ways of figuring that out, and one of them is to get an app, and this is my favorite app for telling me what the integrals are. So, but that's the area formula for this, but that still doesn't help us completely because this is still infinite. What we have to do is we've got to decide what bounded area do we want to find the area of, and so we create boundaries. Here I'm saying that I want my boundaries between 0 and 4. And there it is, between 0 and 4. And now this just becomes a subtraction problem, because what I do is, these are my x's. I do 3 times 4 is 12, and then I subtract the lower boundary. In this case, it's 0. 3 times 0 is 0, and so the area is 12. And this will work for any set of boundaries. It doesn't have to be 0 at the lower boundary. I could say that I want the my boundaries to be between 2 and 6. Here it is, between 2 and 6, and it becomes a different subtraction problem. 3 times 6 is 18. 3 times 2 is 6, and now my area is 12. And here's me subtracting out the 2 times 3 right there. Okay? So hopefully this will give you a general idea of what's a good visualization of what's going on with the integral. And now, while I hopefully still have your attention, I want to talk a little bit about this kind of mess, because this looks very hard to decipher. The reason I'm putting this in is because somebody, and I'm not going to say who, said to me, Mom, the answer doesn't seem to make any more sense to me than the question. And yeah, I get that. So I want to just talk about how to decipher this in a way that feels comfortable. Here, just like in the other problem, this with the integral sign at the front that's unbounded and the dx here, this is asking us to consider the area between the x-axis and the function line. Now, that's a weird looking function line, and all we have to do is note that that's a trig. These are two trig functions, and you put two trig functions together, adding them, multiplying them, doesn't matter. They're going to be pretty much a curvy line. So you see trig functions like that, oh, you just think to yourself, oh, curvy line. Because there's no boundary here, because there's no boundaries, what we're looking for, what it's asking us for, is an area formula, or the integral, the indefinite integral, which, again, you can find in many numbers of ways, but that's not what this is about. But this is the area formula, and that's what it's asking you for. Okay? Now here, this is the same function, but now it's got boundaries around it. So to visualize this, you still visualize it as a curvy line, but now there's a bounded area within it between 0 and 2. And now this over here becomes just like in the other one, a subtraction problem. So this actually just stands for a certain number. It's just a number. Nothing mysterious. I'm going to actually show you how to get that number without having to have any hugely special skills. I'm so sorry for using that word. Here's that function that I was just talking about. Now to ask it for its integral, you put the integral sign on the front and the dx on the back. And you find, in whichever way works for you, the area formula. Now, to get this, to make this into a subtraction problem, to find an area, you have to decide on what area you want. And let's say I want my area to be between 0 and 2. Okay? I want to find the area of that piece. Okay? This is how I would write it, with the 0 and 2, and no C. Now that sort of still looks like a mess, but we're good. Okay? Because what I do is I take this without the C and type it into Google. Okay? Don't need a fancy calculator, just type it into Google. I put my X's in here in parentheses because it just helps me keep things in order. And now, because my boundary is between 2 and 0, I'll put a 2, first I'll put a 2 in where the X is, and it gives me about 10. So there's my 2 in where the X is, it gives me about 10. Then I'll put a 0 in where the X is, and it gives me -1. So my subtraction problem basically turns out to be about 10 minus -1, which equals about 11 square units. And indeed, you can see 2, 4, 6, 8, 10. It's about 11 square units. So hopefully that demystifies some things. What I want to sum up with is that what this is really about is I want you to know that we're not solving for X anymore. You are choosing X. You're choosing your definite. You're choosing a boundary. The reason you're doing that is because you're creating a definite boundary within infinity. So within that boundary, you can determine an area in square units. It's a number. It's good to remember that all functions have their own area formulas, which we call indefinite integrals.